Okay, so we learned how to find the rate expression in the last video, and now I'm going to show you how to find the rate constant, this K, the proportionality constant that allows this whole thing to work. All you need to do is plug in the information for one trial, and it could be any trial you like. Why don't we just go ahead and plug in the information from trial 3. So for trial 3, the rate was 4.50 equals, we're solving for K. The concentration of A was 0.30 squared. So now we realize that all we have to do is divide this side by 0.30 squared and divide this side by 0.30 squared. This all cancels out. K equals 4.5 divided by, open up parentheses, 0.30 squared, close parentheses, equals 50. So the rate constant is 50. Now, the rate constant has some interesting units. The units change depending on what the overall order of a reaction is. To find the overall order of a reaction, you just simply take whatever numbers are at the top of your reactants. So let's say this is a 1 and this was a 2. The overall order would be 2 plus 1, which is 3. But that's not the case here. The overall order, there's only one reactant, so it's 2. Here's how you find the rate for the overall order. The way I like to remember it is its concentration to the power of 1 minus the overall order times whatever time you're using, okay, per time, which we can just move up here. And I think about this because if you really think about what is rate, it's the change in concentration over time, or moles per liter, the change in moles per liter over time. Let's just say time, I believe in this case, was in hours. So we'll say hours. So this might look a little funky, but if you think about acceleration in physics, remember meters per second, also known as acceleration. What did that end up as? Meters per second squared. Okay, so how would that work out here? Well, then we would get moles over liters times hours. I'll just put HRS for hours. How could we bring hours up to the top? Well, we just put it to the -1 power, and then that would bring the time up here. So here's how we're going to do it. Let me just erase this so it's nice and clean. Okay, so we know the overall order is 2, so it's going to be concentration to the power of 1 minus 2, which is -1. I need a bigger eraser. Okay, so concentration, we know that's moles per liter, and this is going to be 1 minus 2, which is -1, times our time component to the -1, which is hours to the -1. Then we just distribute this negative to each thing, so that's going to become moles to the -1 power, liters to the first power, so we don't have to do anything because -1 times -1 is just going to be 1, and then hours to the -1. So the units for K is 50 per mole liters per hour. So that's a pretty interesting unit. That equals the rate constant. So now you know how to find the rate constant K, and now you know how to come up with the units for it. I hope this video was helpful. Have a great day.